expression in terms of sine and cosine and then simplify. So in part A we got secant times cotangent, and we know that secant is reciprocal of cosine. Okay, so we know that secant of some angle is 1 over cosine of the same angle, and cotangent, that's the reciprocal of tangent, 1 over tangent. And we also know that tangent is sine over cosine. That means reciprocal of sine over cosine is cosine over sine. So cotangent is cosine over sine. So let's put that together here. This is 1 over cosine and this is cosine over sine. Then we simplify, so multiply the tops, multiply the bottoms, but they are same, so we can cancel. We got 1 over sine. We can simplify because this is a fraction, and we know that reciprocal of sine is cosecant, CSE theta. Okay. Let's do part B. So first we need to write in terms of sine and cosine. And cotangent, we just saw cosine over sine, and there's a square. So square is quantity square. This is cosine over sine minus, this is 1 over sine. Cosecant is 1 over sine. Okay, we just saw this here as well. Cosecant is 1 over sine, or cosecant is reciprocal of sine, and then we got a square. So note, we are trying to write in terms of cosine and sine first. So that's what we have. A square is for the top, for the bottom, so let's simplify. So this is cosine square x. It's a cosine x times cosine x, but this is the shorthand notation for cosine x quantity square. We write in this way. Same thing, sine square x minus 1 square is 1 sine square x. Now to simplify, we got two fractions, same denominator, so the common denominator is sine square x. That leaves cosine square x minus 1 on the top. Okay, we need to simplify if we can, and this one difference of 1 and cosine square and 1. If you recall, there is the most famous Pythagorean identity, which is sine square theta plus cosine square theta is 1. Okay, now we can play around here, and then cosine square is same as what? If we move this over, cosine square means subtract sine square from both sides, we get 1 minus sine square. Okay, so we can write cosine square as 1 minus sine square. And why? Because sine square is on the bottom. And when we write cosine square as 1 minus, this is 1 minus sine square, then 1 and minus 1 cancel, or 0. So we are left with negative sine square over sine square. Then we can cancel. Okay, this angle should be x. Then we cancel. That's why we are changing. If there is no point after we do this and we cannot simplify further, then we do not write that. So let's do here, or you can rewrite basically cosine square minus 1, right? From here, if you play around, that's another option. You can go through this one, replace cosine square x as 1 minus sine square x, and then 1 cancel. You got negative sine square x over sine square x. Then sine square cancel, the negative 1. So negative 1 would be the answer. But if we play around here, since we have this identity, we got cosine square minus 1. Cosine square minus 1, subtract 1 from both sides, and then move this over means also subtract sine square. I'm playing around this Pythagorean identity just to put in this format. Cancel by design. So this is cosine square theta minus 1 equals negative sine square theta. So you can go ahead here, and right, cosine square x minus 1 is in fact negative sine square x. Negative sine square x. The negative means negative 1 in the front, and we can cancel the same thing. So negative 1. So this one is negative 1. Okay, or you can simplify in other ways as well, or you can do the following. Here we know that 1 minus cosine square is formula, but this one is kind of backward. So how about factoring negative 1 out? If we factor negative 1 out, then we can swap this order. This becomes 1 minus cosine square x over sine square x, negative 1, negative, and 1 minus cosine square is sine square over sine square. Okay, and they are same, so negative 1. So either way, the answer, the final, is negative 1.